Evaluating Erosion in a Historically Affected Watershed by Natalie Bartel. Over the past century, the beautiful watersheds of Santa Cruz Mountains have experienced issues with erosion. Erosion, when soil is pulled away from an area and moved to a new area, is caused by a variety of environmental factors such as rainfall and hill slope, and anthropogenic factors such as changes in land use, logging, and agriculture. Erosion affects soil quality and the ecological viability of an area, disrupting the functioning of local wildlife. Erosion can have extreme effects on fish, insects, and other animals who depend on rivers. The San Lorenzo River watershed in Santa Cruz, California, has experienced erosion issues mostly due to its historically bad logging practices. A 29-mile river starting in the mountains and outputting into Monterey Bay, San Lorenzo had a total maximum daily load on sediment imposed in 2004, as excessive soil erosion was causing problems such as bad water quality and sediment buildup, which disrupts river function and fish health. This study focuses on the San Lorenzo River watershed through the years of 2001 to 2011 to explore how changes in land use in this time have affected erosion. The objectives were to predict soil loss in the watershed in 2001 and 2011 and see if land use changes had affected soil loss over this time period. Soil loss predictions were done using the Roosley equation. Roosley is an equation created and used by the USDA to predict soil loss based on a region's annual rainfall, slope and hill length, land use, soil type, and agricultural soil conservation practices. After generating a layer for each of these variables, soil loss can be calculated in ArcGIS on a pixel-by-pixel basis through the use of the raster calculator, and areas with high or low erosion potential identified. To start this project, soil, rainfall, hill slope and length, and land use layers were generated for the Santa Cruz region and clipped to the watershed line. The rainfall variable was created from rainfall estimates for the region, which were then created and multiplied by a literature-based equation for California rainfall erosivity. Soil survey data was found on the USDA's Web Soil Survey site, symbolized by its erodibility, or K factor, and converted to raster format. The LS variable, or slope and hill length, was calculated by making slope and flow accumulation layers. Slope and flow accumulation were then multiplied together in raster calculator by the equation shown here to derive an LS value. Finally, two land use layers from the National Land Cover Database, one for 2001 and one for 2011, were generated and re-symbolized with values that relate them to erosion. All layers were then multiplied together to determine soil loss per region. The result was a pixelated map of the San Lorenzo River watershed for each year, with regions that likely experience minimal erosion, represented in green, and regions that experience heavier erosion, represented in yellow to red. As can be seen from the 2011 dataset, most of the watershed experienced limited soil erosion. How did this differ from the 2001 dataset? It didn't differ much at all. Looking at the soil loss maps side by side, there is no perceivable difference between soil loss in 2001 and 2011. Why is this? Subtracting impactful land use changes over this time period starts to illuminate the answer. Depicted as areas with a change in land use in San Lorenzo, purple is a change from less problematic to more problematic land use, such as forest turning into development, black is the reverse, and white depicts no change. Across the 10 years of study, only a small portion of the watershed was converted to land use types that increased erosion. Looking at the change in soil loss between 2001 to 2011, a total of 10 pixels in the map, or about 0.356 acres of the 128 square miles, changed in the amount of soil loss, and some points even decreased their potential soil loss in this time period. So what does this all mean? Well, it seems like Santa Cruz County is implementing great land management practices. Much of the areas developed during the study period fall into the category of low erosion. Very minimal development also occurred across the whole watershed. Finally, online research shows that since the year they had the total maximum daily load on sediment established, Santa Cruz County has started various erosion reduction projects. Basically, all signs, including this study, point towards the fact that Santa Cruz County is doing a good job protecting the region from more erosion. Despite the optimistic conclusions drawn, this study definitely is full of some issues. Using Roosley and ArcGIS involves a variety of complicated calculations and geoprocessing steps, thus math issues could yield bigger or smaller soil values across any pixel. Things like watershed erosion control were also not factored into the equation, thus other factors could definitely alter these values and trends in future studies. However, this project showed that as an overall trend, the San Lorenzo River watershed has taken great steps to improve erosion and sedimentation, especially in regards to land use. It also shows that minor changes in land use only minimally affect soil loss in a region, which is good news for future development and sustainable land management. Future work in the topic should incorporate more factors into soil loss predictions, such as erosion mitigation, roadways, and surface road management, in order to better measure soil loss and continue to improve the health of the San Lorenzo River watershed.